So right now we are looking at the graph of y equals x cubed minus 4x, and we're looking at the secant line that is between the point occurring at -1 and the point occurring at 1. And so remember, secant line, the slope of the secant line is the same as the average velocity. But in this lesson so far, we've been trying to approximate the instantaneous velocity. So how can we use the idea of a secant line? What would the equivalent to the instantaneous velocity be in terms of a line? So remember, when we were looking for the instantaneous velocity, say we were looking for the instantaneous velocity at this point 1, -3, then we wanted to take our second point and actually move it closer and closer to the point that we cared about. So now we're taking an average velocity between 2 points that are much closer. And if we look at what happens to our secant line as we do that, we look at it from both sides. From both sides, our secant line kind of looks like right there, when it's real close, it disappears right when I'm on the same point. And that's important to note because you can't find a secant line, you can't find a line from just one point, right? But if I'm really close on either side, they kind of look very similar. And we're going to define what we call the tangent line, which is that red line right there, to be that line that we kind of want. If we were trying to find the instantaneous velocity, it would be the line that would have the same slope as the instantaneous velocity and would go through that point on our curve. And we're going to call that the tangent line. So the tangent line is the line that just touches the curve at that point and doesn't cross it. It might cross it again like somewhere way over here, but real close, it only just touches it. And to find the tangent line, we are going to look at secant lines as they get closer and closer and closer. And so you can see the secant line gets close to the tangent line on each side. So the tangent line, as you can see, is just touching the curve there at one point, no matter how far I zoom in. And as I zoom in closer and closer, my curve is actually looking more like a straight line. And what the slope of the tangent line is actually giving me is a way to talk about the slope of the curve. So the slope of the tangent line is giving us a way to talk about the slope of a curve the same way we've talked about slopes of lines in previous classes. And it also gives us a way to talk about instantaneous velocity. When the function we're talking about is a position function. The only problem we have now is we can't actually find this tangent line. We can approximate it with secant lines, but for the tangent line, we only have this one point, and we need 2 points to find a line. And that's going to lead us to a new concept of mathematics called the limit. And limits are where calculus begins.